Here's another example of taking a derivative of a function that contains, at least in part, a trigonometric function. So we have this function y equals 2x minus cotan squared of x, and we're going to try to find the derivative, find y prime. The first thing that I'm thinking of, as soon as I look at this, I'm like, you know what does this really mean to me? I'm going to try to rewrite this in a simpler form. So the first thing I'm going to do is I'm going to take this cotan squared x over here, and I'm going to say, you know what? How can I rewrite this? Is there a better way for me to see this? Because in this form, it's hard for me to see that there's a chain rule here. So here's that chain rule piece. So it's important that you realize that cotan squared of x is equivalent to saying cotan of x squared. So I'm just going to replace that here. I'm just rewriting this. Then I'm going to start to differentiate. This is just sum and difference rule here. So I'm going to just differentiate this one part at a time. And the first derivative of 2x is just 2. So that's where that comes from. Here, I'm going to use the chain rule here. And the chain rule says that I take the derivative of the outside. So this 2 comes down here, and it becomes this 2. This exponent is reduced by 1. So here's the derivative of the outside, which is 2 cotan of x. And then if you remember the chain rule, we're supposed to take g prime at x. So what is the first derivative of the inside? And the first derivative of cotan of x we have memorized perfectly is the opposite of cosecant squared of x. So that gets us there, and we're almost there. And from here it just turns into, frankly, it turns into a lot of trig. But we can do that. So I'm going to just take some rewrite these using some trig identities. I'm going to take a cotan identity, and I know that cotan is the same as cosine of x over sine of x, so I'm just replacing that. This 2 is that one, this negative 2 is this negative 2, and cotan of x, I'm just writing it in a different form. And if you don't know these forms, it's just something you have to memorize, and then these identities will really come to you. Also know that the opposite of cosecant squared x is the same, right? This is a reciprocal identity here. This is a reciprocal identity, and the reciprocal identity of this is 1 over sine squared x. I squared the top and the bottom, but 1 squared is still just 1. So that's where that came from. So I'm going to do this work. Sine of x times sine of x squared is sine of x cubed. Negative 2 times, look, negative 1. Negative 2 cosine of x times negative 1 is positive 2 cosine x, isn't it? From here, just anytime you want, you can stop the video for a second, because this is going to turn into a bit of trig here. But so here, then I'm going to just take this for a second. I'm going to factor out a 2 here. Here's a 2 up here, and here's a 2 over here. I'm going to factor that out. So I'm going to take this, and 2 times 1 is this 2. 2 times cosine is this 2 right here. So I have that accounted for. And then just to clean this up, here we have, from here, cosine of x over sine cubed of x plus 1. Well, 1 obviously is sine cubed of x over sine cubed of x is, by definition, 1. So I don't know if you can see that. I hope that you can. So that's all I'm doing there, because I'm looking for a common denominator so I can put these two pieces together. So now we do have common denominators, and the common denominator is sine cubed of x and sine cubed of x over here. So when I go to put that together, well, I didn't finish. When I go to put that together, I'll get the first derivative is equal to 2. And then I think what we're going to do, if you don't mind, is I'm going to put this cosine first. So cosine x, this plus sign is this one, plus sine cubed x all over sine cubed x. And there's our derivative. So, not the easiest thing in the world, but if you got, frankly, if you got to this place, where are we? If you got to this place right here, you're in the money. Because what I'm really, really looking for is, are you finding ways to recognize the rules that we have? Again, if you looked at this, this was a mess. So if you rewrote this as this, if you found this rewrite, you're really on the right track. Because once you see this, I think now you can see, okay, this is a chain rule problem. Here, I'm not so sure that you can see it as a chain rule problem. So keep it up. Practice, 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 and let me know how it's going.